Good day, viewers. Thanks for watching. Please make this. Don't forget, we are still on capacitance and capacitor. So in my previous classes, I taught a lot of things about capacitance and capacitor. Now, I want to teach you the last thing I need to know about capacitance of a capacitor. What is that? Capacitance. What is capacitance? Capacitance is the ratio of the electric across potential difference of a parallel of a plate of a capacitor. Now, what is the formula for capacitance? The formula for capacitance is C equals to this A over D, where C is equals to capacitance, D is equals to permittivity of medium. A is equals to area of the plate, while D is distance of the plate. However, also know that we have ER, which is equals to EO, this permittivity times E, where this means relative permittivity, and this means dielectric constant, What about this? So it's either you call this dielectric constant or permittivity of a space. I've told you about this already, of a medium, of a space. Yes. Permittivity of a medium or space. Let me say this in brackets. So I want you to understand this. And I want you to understand factors affecting capacitance, or let's say characteristics of capacitance. So let me give you terms that you need to know. First of all, we have C proportional to K over D. Let me say to D. No, inverse. 1 over D. First one. Second one, we have C proportional to this. And the third one is an assignment for you. Go and make research. Go and check out on this. You understand that? So what I want to teach you today is calculation of capacitance of a capacitor. That is my focus right now. So thank you. But before we go into the calculation, let me start from this simple calculation here. Look at the example here. Solution. This example says 2 capacitors of capacitance, 3 microfarad and 6 microfarad are connected in series. Full stop. Calculate the equivalent capacitors. Before I go into this calculation, I want you to know that this symbol stands for micro. And micro means times 10 raised to the power minus 6. We have P, which is pico, which is times 10 raised power minus 12. We have N, which is nano, times 10 raised power minus 9. We usually use this. Do you understand? Another thing I want you to understand is that units of Q, which is quantity of electricity or capacitance, is measured in coulombs. Yeah? It is measured in coulombs. While capacitor is measured in farad. Capacitor is measured in farad. Do you understand that? Good. So I want you to note this. These are the things you need to know before we kick off this calculation. Before we kick off on this. Now look up. I have taught you series arrangement. Now let's apply our knowledge to this question. Two capacitors of capacitance 3 microfarad and 6 microfarad are connected in series. Full stop. Calculate the equivalent capacitance. What do you do? C1 is equal to 3 microfarad. C2 is equal to 6 microfarad. They set series. That is 1 over C is equal to 1 over C1 plus 1 over C2. 1 over C is equal to 1 over 3 plus 1 over 6. 1 over C, LCM is what? 12. 12 divided by 2 will give us 4, right? 6 divided this will give us 2. Two times 1, 2. 4 times 1, 4. So 1 over C is equal to 6 over 12. I bring this up here. One over C equals to 6 over 12. 1 over C equals to 6 here 1, 6 here 2. What do? You cross multiply. When you do that, you have C is equals to 2. 2 what? 2 microfarad. Final answer. Hope you understood that. This is the first. Then second example. Second example.